I'll still be.
Recording has stopped.
The attendees. Should I start again?
Yeah.
A very pleasant morning to everyone present here. I'm Maisha Rahman from Shivnadar School, Noida. I would like to extend a warm welcome to all the attendees. With the collaborative efforts of Shivnadar University, Vidyagyan School and Shivnadar School, we have organized a series of webinars termed Scouting the Cosmos. Through these webinars, we aim on imparting the most relevant information about the most significant field of study, space science. In today's session, we will be focusing on exoplanets. This marks the beginning of the second session. I encourage everyone to participate and to be attentive. I would like to hand it over to Harsh and Apurva now.
Thank you, Maisha. Let me share my screen first. So please confirm if it is visible.
It's visible, Harsh.
Wow.
Okay, fine.
Very visible. Well done. Start.
Thank you. So this session is divided into two parts. First is about exoplanets, and second is about like Alpha Centauri and Goldilocks zone. So first part I'll be covering, and second will be covered by my companion Apurva. Apurva, if you can introduce yourself.
Hello everyone. Good morning. I am Apurva Pathak from Vidyagyan School and I study in class 10th.
And I'm Harsh Yadav from Vidyagyan School, class 10th. So let's start from the scratch. Like our topic is about exoplanets and like how are the planets formed? First, let's understand that. You must have heard about the planetesimals theory, like a big object, like probably a star collided with our sun, and the debris which burst out from the sun, like they only became the planet. But let me tell you, this theory is not widely acceptable. There is another theory called nebula hypothesis, and this is widely acceptable, and the thing which happens in it is like most likely to happen, and this is how the stars and planets are formed. So like nebulas are the like dust clouds, and which include like tiny dust particles and many gases. They just swirl around in galaxies, like we are present in our Milky Way. So there are numerous nebular clouds in our Milky Way. Like they just swirl around like anything. They do not have any order, or like things are just distributed unevenly, due to which they just swirl. So but at the same time, what happens, the gravity of those nebular clouds, that pulls all the material from far edges towards the center, and gradually all the materials, all the gases, they start moving towards the center. And due to like friction and immense pressure, that like huge heat is generated, huge pressure is generated, and that leads to the fusion of hydrogen and helium gases. And due to that, ultimately a star is born, which is called a protostar. So a star is born, and at the same time, due to the gravity of star, all the material around, like whatever material is left, all the gases, all the dust particles, they just start revolving around the star. So a centrifugal force is also generated at the same time. So it's a force like which pulls the heavier material, like the oxygen, sulfur, silicon, iron, and nickel. Like these components are pulled towards the edges, and they also like keep on revolving around the star. And ultimately, they like combine together and form small rocks, which are called planetesimals. And these planetesimals combine together to form planets. And there are few gases also which are left. So these gases combine together to form the like gaseous planets, which we know, like in our solar system, they are known as Jovian planets. And the planets which are composed of heavy materials like oxygen, silicon, and iron, nickel, they are called terrestrial planets. So this was a theory. I have a video regarding it. Watch it. It does not have any audio, but it explains very well like how a planet and stars are formed. So just sorry, just watch it. I'll be just speaking with it simultaneously, and you will understand that how stars and planets are formed. So first we have this nebular cloud, and it's just swirling at random. So this is our nebula cloud, and it keeps on swirling. And as it moves, gravity pulls all the material from far edges towards the center, and it takes a shape of disk. You can see all the materials coming towards the center, and gradually pressure builds up right in the center of this cloud, and huge pressure and heat is created over there, and it leads to the fusion of hydrogen and helium, and the star is born. But a few materials are sent outwards also due to centrifugal force, which lead to formation of planetesimals. And these planetesimals combine together to form planets. You'll see it. See, these are planetesimals, and these are combining to form protoplanets. And yeah, our whole solar system is formed. Quite often we also think that why terrestrial planets are near to the stars, and why the gaseous planets are away from the stars. So as we see, like a hot air, so it always moves up. So as the gas giants are formed due to the heat and the radiation of the sun, they move away from the star. Otherwise, due to the heat, the gases which are forming these planets, they won't be able to condense, and they won't be able to form the planet ultimately. So it's better that they are away from the star. So how do we define a planet? Basically, there are other things also formed during this nebula, when this process takes place, of this nebula hypothesis. So what makes a planet different from other celestial bodies which are formed during that process? So there are comets also, asteroids also, and dwarf planet also. But what makes a planet? So all the planets which we have till now, which we have observed, which we have find out, they have three things in common. First is that they orbit around their star, their sun. So all the planets, like all 8 planets of our solar system, they orbit our sun. And second, we have they have enough mass for their gravity, so that they can overcome their rigid body forces. like uh, it is something that if you take an asteroid, and it has a very uneven shape, a mountain is bulging from its one end, so it will keep on bulging like that only. The asteroid will not have such force of gravity so that it can pull down the mountain in towards its center and become a round shape, take a round shape. But this is not the same with planets. Take for example our earth. It is almost round in shape, because the gravity of earth has pulled down all the material towards its center, and it has got a round shape. And now the third property is it has cleared its neighborhood. All the planets are dominating body of their orbits. There are many celestial objects in our earth's orbit also. The moon is there, and several asteroids are there, but earth is the planet, because it's the dominating body of its orbit. And if we talk about Pluto, it's not the dominating body of its orbit. That is why it was excluded from the list of planets of our solar system. And if we look at the definition of exoplanet, an exoplanet is a celestial body which satisfies all these three criteria, but it is outside our solar system. So that's it. Let's move forward. So our first exoplanet was discovered in 1995. Before that, in 1992 also, like a celestial object was observed, but it was hard to tell that it was a planet or a comet or asteroid, because the thing which it was orbiting around, that was a pulsar, and due to which it did not became clear that what is it that exactly. So after that, till 2009, we did not have any special mechanism, any special mission for observing these exoplanets. But in 2009 we have a Kepler mission, which was designed with the motto of like observing exoplanets out in the space. And from 2009 and till now we have like 4,000 exoplanets confirmed based on their characteristics. And this is the graphical representation of the like planets which are found till 2017. Unfortunately, I could not get the latest data till 2022, but this is the graphical representation. You can see like most of the planets are between the size of Earth and Neptune. So this is a very good thing for us, because the like we do not have to worry like in future, if possible, if we step on these planets, we do not have to worry about these like size and the gravity of the planet. Because if the say like if the planet is as big as Jupiter, and if it is rocky, as soon as we land on the planet, we'll just stick to the ground because of the gravity. So like we do not, and if planet is equal to the size of Earth, we'll be able to walk on it easily. So that's it. And majority of the planet lies between the size of Earth and Neptune. Like in the nebula hypothesis, we talked about the categorization of based upon the composition of planet. So we have terrestrial planets and Jovian planet. In the same way, we have categorized the exoplanets also based upon their composition, based upon their distance from their star. And yeah, so that's it. These are the two like bases on which we categorize them. So first category is of hot Jupiters. So this is the like these are the exoplanets which are made up of gases, but are like quite closer to their stars, due to which their temperature is very high. So of course we cannot inhabit these planets. And second category is of ice giants. Ice giants are like planets with the size almost of the size of Jupiter, and they are very very far away from their star, and due to which they are very cold, like our Uranus and Neptune. And third category is of low mass planets. So these are the planets which differ from the size of our Earth, and a planet equivalent to 10 Earth. So, and these are terrestrial planets, and these are not very far away from their stars. And fourth category is of mini Neptunes. These are called mini Neptunes like because of their distance from their star. Like they have usually they are very away from their star, and they have very long orbital distances. And super Earths are those planets which lie in the habitable zone of the star, which will be covering like habitable zone. Apurva will cover. She will talk about that. So these are the exoplanets which lie in the habitable zone of a star, and are terrestrial in nature. So we have all this categorization, and we have found so many planets. But how do we like find them? How do we? What are the methods that we using which we confirm that these are exoplanets? Something is there like a planet. So there are five methods mechanized by the scientists, and these methods are very simple, and they use very simple mechanisms to confirm that if some planet is there. So first method is of radial velocity. This method is very simple. Like we know, a planet revolves around its star because of the gravity of that star. But gravity works both ways. Like planet also pulls the star and makes it to revolve around the center of mass. So when we observe a planet, there is a time when the planet is between the star and the telescope. And when the planet is in between the star and the telescope, the planet pulls the star towards itself and ultimately towards the telescope. So what happens, the rays coming from the star, they their frequency increases, and their wavelength decreases. So due to which the spectrum of the light shift towards blue. And when the star is between the planet and the telescope, the planet pulls the star towards itself, due to which the wavelength of the rays coming from the star increases and frequency decreases. Here is again a video for it, so you can watch it. It's very simple video, and it will make you understand. So when the planet is between the telescope and the star.
Harsh,
Oh
please,
yes, ma'am.
uh, um, can this video be enlarged? It's a very nice video, and also the kids are from sixth and seventh grades. It, uh, I hope kids you are understanding, because this is something very interesting what he is explaining, and especially the videos are so good. So, Sid, all children who have joined, would you like to have any question? Please ask.
Yes, please ask if you have any question. Like stop me just there where you don't understand anything.
Sidveer, and I can see Arya, I can see Yash. Can I understand why when frequency increases, wavelength decreases, and why when frequency decreases, wavelength increases? Can somebody explain me? And what is wavelength and what is frequency? Sidveer, Riya is there, Yash is there. I can see Ishan. When he is talking about wavelength and frequency of light, what basically is wavelength and what is frequency? You should ask these questions to hers, right? Or Kavya or all the tutor. Then only you will enjoy this course. Is there any understanding that all electromagnetic waves, light is a type of electromagnetic wave?
So wavelengths is the distance between the this the so wavelength is the, I think it is the distance between the successive crests of a wave.
Excellent.
Yes.
Excellent. That's correct. And then what is frequency?
I think frequency. I don't know about frequency. I know about wavelength.
It's okay.
I read it in an encyclopedia.
That's
So
okay.
the frequency is the number of oscillations per second.
So,
Sorry,
Yes,
couldn't
Apurva.
hear you.
you
Couldn't
understand when
hear you.
light is moving or any wave is moving, wave, when you say crest and turf, obviously the number of complete waveform, the number of complete oscillation in 1 second is frequency. Okay. Sidvir, what is and Ishani and Ishan and all? What is why we are using oscillation in terms of light? Any idea? Light में oscillation कहाँ से आ गया? Electromagnetic waves में from where this oscillation term came? So all these things, you should not just listen. You must ask. Are you replying back, Ishan? So, the basic of light you must understand is from any one of you, Hers, you can explain light is a type of electromagnetic wave a little bit to these kids. It will be good. And then if you show the video, they will have a lot of interest, beta. Excellent video.
Yeah,
Excellent.
so
Please explain them that what is frequency and wavelength and why one increases, why, because the speed is constant. So these two are multiple. Yeah. Over to you, Hers.
yeah, so I'll talk in context of this radial velocity only.
Yeah.
Like we know, light comes from a source, and when it travels from one place to another, it travels in the form of electromagnetic wave, and that wave comes in the form of crest and troughs. So when that comes, so what happens? When the star moves away from the where from the place where we are observing the star, that stretch between the observer and the source increases, due to which its wavelength increases. the length of its wave, like the crest and the distance between its crest and a trough, like uh, increases, due to which its wavelength increases, but the frequency, the number of oscillations which it was taking in 1 second, that decreases due to that stretch. And when it comes closer, that like that wave like structure, that like squeezes, we can say, and due to which the frequency, the number of oscillation increases, and the uh, like the wavelength, the distance between one crest and another decreases. So in that way, when we observe that same thing on a spectrum, so like blue light has uh, like the it is created when light has at most energy. So when energy is more, the frequency is also more. So when energy is more, frequency is more, then a blue light will be produced. And when energy is low and frequency is low, then and wavelength is long, so red light will be produced. So when a star is pulled away from the like source where we are observing, then it will like appear red. And when star is pulled towards the place from where we are observing it, it will turn blue, because of the energy reaching to the place where we are observing it. Is it clear now?
Also, uh, there is one thing which is very important. With your permission, Hers, can I explain but better?
Yes, ma'am, sure.
So all children who are attending this session, there is something basic what what Hers has explained, and that's correct. But most important to understand is uh, the way he has explained is just too good. If I would have been in 11th, 12th, I would have taken astrophysics as and be your student, Hers. I'm so happy that you are explaining so well. Been in grade 10, you are explaining it. So all the young kids, I would like to explain you one more thing with permission of Hers and other children here. Suppose here is the source of light. See here. I'm making a source of light. Can you see this? This is sun, or let's say candle. Now, uh, as a layman, what happens is the light, any light, whether it is red light, blue light, green light, any light, white light is a combination of seven color. The velocity c is depicted by c. Velocity of the light wave is fixed. Okay. And that is what 3 into 10 to the power 8 meter per second. You know this? This is the velocity which is fixed. When I say velocity, it means that 10 to the power 8 meter per second. It means suppose I ask you to run from one corner to other corner, you will have your velocity, yeah, in the classroom. Exactly same way, the light starts from here and I'm standing here. Okay, this is Vinita ma'am. So light, there are some participants who are joining slowly. Okay. So basically what happened, the light travels from here to Vinita ma'am or to, let's say, hers with this velocity, and that is fixed. Please understand that is fixed. Whether it is red light, white light, even it is microwave or radio wave or any type of electromagnetic wave. Light is also a type of electromagnetic wave. See, there are two types of waves which all children should know. One is sound wave. When I'm speaking, this is also going in form of wave. Another is light wave. The moment you say light wave, basically, or you say X-ray, or you say gamma ray, or you say radio wave, these all are electromagnetic waves, and the all velocity is fixed. Please understand this. Okay, and you have done in grade 7 that velocity is what? Distance upon time. Yes or no? This is displacement upon time. You all know this. Ishan, Sid, you know this formula? Velocity is displacement upon time. You all know this? Now, if you take a waveform, a very simple explanation I'm giving you. If you take a wave, light is traveling in a wave. It means if I explain you in terms of crest and tuff, please understand this. This is one complete wave, right? So for one complete wave to start from here, which is sun, and here is Vinita ma'am, to reach here, how much distance it has covered? How much distance it has covered? Isn't it the wavelength? Because if this is wavelength, one crest and one tuft, isn't it the wavelength? This wavelength is depicted by, this is a Greek symbol lambda. So light has started from here to here and one complete wavelength it has covered. It means displacement is lambda. And if you divide by the time taken from here to here, isn't it, it is, this will give the velocity of this wave. Ishan, do you agree with me?
Yes, ma'am.
So basically light यहाँ से start हुआ. From here it started and Vinita ma'am is standing here, very close to the source, and it has just, one wavelength distance I am standing. So how much distance the light has covered? This is one wavelength, which is lambda. How much time taken for one complete wavelength? This is t. So velocity is lambda by t, and basically for completing, number of this particular thing, what you are, seeing this is velocity, and this is fixed for any type of light, whether green, blue, red, etc. Right? So if that is fixed, it means that green or blue or if for that, if lambda is more, this is called lambda displacement. And this 1 upon t has got another name which is called frequency, f. 1 upon t is frequency. Now tell me, if this is fixed, don't you think one will increase, other will decrease, or one will decrease, other will increase? Don't you think this will happen? If this is fixed, which is 3 into 10 to the power 8 meter per second, and it is multiple of two factors, wavelength and frequency. And what is frequency? 1 upon time taken for one complete wave, right? Yes. So if this is fixed, don't you think these two will adjust itself so always to give this value? And that is why Hertz is saying that if wavelength is increasing, frequency is decreasing, and if frequency wavelength is increasing, this is, it is very simple for 6, 7, 8 to understand. 2 into 5 is always 10, always, and so is 5 into 10. You all agree with me or not? 5 into 2 is also 10. So what is so different? Final is 10 all the time, always 10, but how the two are number is adjusting itself to give always 10. Lambda is 2, frequency is 5. Lambda is 5, frequency become 2. So exactly same thing what Hertz is explaining you guys, that velocity of light or velocity speed is fixed. But then if wavelength is increasing, frequency is decreasing, frequency is increasing, wavelength is decreasing. That's it. I hope I'm clear to all the participants, children. Am I clear? Or especially the young one, those who are in 6, 7, 8, did you understand when I say that frequency and wavelength, they are just to always give 3 into 10 to the power 8 meter per second because velocity is fixed? Yes or no? This is Yash, Anurag, Sid. Did you understand? Hello? Okay, over to you, Hers. Hers, these kids are very small. So, a little bit with...
Yeah.
Now you can go ahead with that.
Thank you. Thank you so much for this amazing explanation. Like, I could not explain it that well, but thank you so much for this.
Go ahead.
So I'm sharing my screen again. Just confirm if it is visible. So is it visible?
Yeah.
Oh, thank you. So this
Actually,
was
I
our
need
first
to
way,
leave.
like how we...
Yeah, start now.
So like this was our first way how we detect the presence of exoplanet near a star. Here comes the second way, and in this way what happens that it's same as the like radial velocity method, but in this case what happens that we measure the brightness coming from the star. So when like star is there, and it's like it will be emitting light for sure, and like its brightness will be disturbed only if some celestial object comes in its way. So and that object should be big enough to block the amount of light which is coming from that star. And planets are the biggest object around a star. Like if we compare the size of, if we talk about asteroids, comets, moons, and dwarf planets, planets are the biggest among them. So in this way only, when we observe a star using a telescope, so the amount of light reaching, the intensity of light reaching our telescope, sometimes what happens, that is disturbed. And then we get to know that there is some celestial object which is revolving around that star, and when it comes in between the telescope and the star, then the frequency sorry, the intensity of the light coming from that star reduces. And in that way we get to know that it is a planet, because the object is big enough to reduce the intensity. And yeah, so we observe that. So see this video. When this planet comes in front of the star, this brightness graph reduces. Like you see, the intensity of light decreases. So we confirm that there is a planet. So this was our second method. Let's move on to the third one. Third one is direct imaging. It's very simple to understand because we quite often do it in our phones only. Like if we want to click pictures during daytime, or at a place where there's a lot of light, but our position is such that we cannot get the image of that object due to the glare coming from the source of light. So what we do, we make some changes with the settings of our phone camera, and we get to see the object very clearly. Same happens with in this case also, when a star is observed, and when we want to observe its surroundings, so we reduce the glare coming from that star. And all the big planets of course are the biggest celestial objects orbiting a star. So all the planets become visible to us when we reduce the glare. So here is another video, just watch it. We have reduced the glare of the star, and see, the planet revolving it blocks it, and we are able to observe. So this was the direct imaging. And the fourth method is called gravitational microlensing. This is quite complicated, but we'll just touch it. What happens, we have heard that gravity governs everything in outer space, whether it's formation of anything like planet, star, or anything. In this way, gravitational microlensing, it suggests that gravity is involved and something related to light, as it is lensing. So we know that gravity is the turns, crest, and warps of this space-time. So when light travels through space-time, uh, so it also bends because of the gravity of the heavy object which it passes through. Like if light is emitted from a star, then when it passes a planet, like nearby a planet, then it turns, bends because of the warp created due to the planet's gravity. So let's see. And when this bend is created, and we observe this star with a telescope, then a blip is observed in the image of that star, and that star suddenly becomes two. For longer time we observe a single star, but for a fraction of second that star splits into two. And it was due to that bending of light which was caused by the warp created by that planet. And the fifth and last method is astrometry. It's based upon, we know that we represent if we want to represent something, so like position of anything graphically, so we first draw the graph and then represent that this thing is here. We have learned about the Cartesian plane. In the same way, we also represent when it comes to represent the position of a star and a planet graphically. So we do that, and when we observe it at a bigger scale, So we quite often like we do not have places in space, like on Earth we have New York, Delhi, and all. But in space we explain the positioning of a celestial object with respect to another. Like Earth is between Mars and Venus. So in the same way only, we also describe a position of star. Like our sun is between this and this star, this and this planetary system. So we just try to graph that out. But when we graph it, we see that over time the position of that star changes, and that happens due to again the same same process which of which we talked in the radial velocity method, where the star wobbles due to the gravity of the planet orbiting it. So this star right in the center is changing position with respect to all the three stars surrounding it. So we get to know that there is some object which is causing it to wobble, and due to which it's changing its position, and that is big enough to make the star wobble. So that is surely a planet. So this is the last method how we find out exoplanet. So you can see the star was changing its position with respect to its surrounding. Now here comes Apurva with her explanation about Alpha Centauri and Goldilocks zone. Over to you, Apurva.
Now we'll look into this system, star system of three stars. We are studying this because this is the nearest star system to our solar system, which is about 4.4 light years away from Earth. So it is basically a triple star system which includes Alpha Centauri A, Alpha Centauri B, and Alpha Centauri C, which is also called as Proxima Centauri. So uh, firstly, talking about this Alpha Centauri A, it is a yellow star, just like the twin of our sun. It's same in the age also, and its binary partner is Alpha Centauri B, which is like when we look into the sky, in the night sky, these two binary partners are the third brightest stars in the night sky. You can locate them in the southern constellations. So earlier it was assumed that these two stars are basically like they are the one, until we see them with the microscope. Like we don't see them as two different stars. They tend like they look like one star. So in 17th century we came to know that these two are the separate stars, Proxima Centauri, like Alpha Centauri A and Alpha Centauri B. And this Alpha Centauri B is a red dwarf, whereas this Alpha Centauri A is a yellow star. And this Alpha Centauri B is like uh, the twin of this Alpha Centauri A, which is more nearer to it, like not too far as like Proxima Centauri. So there is this third star, which is Proxima Centauri, Alpha Centauri C. So this is very far from these two stars, and sometimes like scientists also doubted that should we include this in this should it be included in this star system. But when they analyzed the data, it was found out that these three stars are bounded with the same gravitational force, and they orbit in the like same pathway. Their orbits collide with each other. So they are the triple star system, and it's the nearest to our solar system. So scientists have also, like NASA has discovered a planet around Proxima Centauri, which is more like Earth, and interestingly it is in the habitable zone of the star. So this means the water could be found in the liquid form, and it is a good news for all of the scientists in the world. So they are discovering more of it. Now the problem is that it is a red dwarf, and it's much smaller, just the size of our Jupiter. So just bit bigger than it. So it's smaller. So the its habitable zone is also very smaller, and the star which we have found out, Proxima B, it is very nearer to it. So it just imagine it just take 11 Earth days to orbit the whole star. So it is like the problem is that scientists don't even know that it is tidally locked or what, like till where the life could be habitable. It is like easily, it might be easily the target for the stellar flares and vents as it is much closer. And if it is tidally locked, the other side would be freezing and the other side would be filled with scorching heat. So the scientists think that if it is like this, so in between, like there might be the circulation of air between both the sides, and in between there might be a ring form of thing. So in that zone the life might sustain. So the life would not be like we see on earth. It would be more of the black color, because black color absorbs the dimmest of the light. So this is the thing about Proxima b. It is the exoplanet that has been discovered around Proxima Centauri. So this is TESS exoplanet survey satellite is continuously looking and spotting the exoplanets around these stars, so that we find a brighter future in space science. So moving on to habitable zone. So it is nothing but simply the range of orbits around a star within which the planetary surface can support the water in liquid form with sufficient atmospheric pressure. And just like imagine Earth to be in the place of Pluto. The sun would be barely be visible from there, and the oceans would freeze out with the so much of coldness. And now imagine the Earth to be instead of Mercury. All the oceans would probably vaporize in the air. So the Earth is in the proper position and location where the life is sustaining well. So rocky exoplanets found in the habitable zone of these stars are likely targets for these scientists to, to research for the life out there, because the liquid water is available. And knowing the life form, because water is the only known life ingredient that we know, because we know the life form that is available on earth. So we are way to explore much of the life. So this habitable zone plays a very good role whenever we go to, like whenever scientists find the like go to finding any form of life out there on exoplanets, they first look at the planet if it is in the habitable zone of the star. So these are the parameters which scientists usually look at. The temperature should be not too cold, not too hot, and the pressure should be fine, and the mass of the planet should be around the earth, like the earth only. It should not be so much heavier that the gravitational force is much more, and atmosphere should be fine for the life to sustain. And distance, yeah, distance also matters so that water can exist. Okay, so here is a very interesting story of Goldilocks, like how this zone got its name. So there was a girl whose name was Goldilocks. She got a name by she had golden hair and beautiful locks. So she was named as Goldilocks, and she lived in the edge of the forest. And she always wondered what is there inside the forest. So she once slipped out of her mother's eyes and went to the deep forest. She got tired by running and was hungry as well. So she found the house of the three bears: Papa bear, Mama bear, and baby bear. So she entered the house. She saw the porridge in three bowls, and when she tasted the bowls, one was too hot for her, one was too cold for her, and then there was the medium-sized bowl in which the if like sufficient porridge was there, and it was neither too cold nor too hot. So it was just right for her. Then there were chairs which she analyzed that which one is the just right for her. So through that we get the idea that same happens with the planets, like if the planet is in the just right location to its star, and it is at the just right, the temperature is just right for the Goldilocks life to sustain. So this is the story behind it. It's very interesting. You can watch it on YouTube anytime. Moving on. Okay, so now we'll talk about the habitable zone of Sun. Habitable zone of Sun starts from the orbit of the Earth to the orbit of Mars, and like the Earth lies in between the Venus's orbit and the Mars orbit. So obviously it is in the best location. That's why the life is possible over here in the better way. So, but the location, I think, according to me, the location is not only the factor to determine the if the life can be found on the planet or moon or on the exoplanet. So just giving you the example, just look at moon. It is in the habitable zone of the sun, but it doesn't support life because the location isn't the only factor affecting the sustainability of the life. The mass of the moon is also very small to, like, its gravity is also very small to support a good atmosphere for the life, and it is also tidally locked to earth. Like the other side is freezing out with the ice, and the other side is very hot because it is always facing the sun. So also, it is said that in about 6.5 billion years, the sun would become a red giant, and it would seize Mercury, Venus, Earth, and even Mars within it. Within it, okay. So then, like these nearest planets would be engulfed by the red giant sun. So then the habitable zone of the future habitable zone would shift to the orbit of the Jupiter and Saturn. So probably the Saturn would be a good habitable planet at that time, and the Earth would be engulfed by the sun. So it is estimated that the Saturn's moon, which is Titan, would become quite habitable with liquid water and oxygen and nitrogen. So the life might be supported in Titan, and it is a happy ending for Pluto because Pluto would be habitable at that time if the future habitable zone would shift to Saturn and Jupiter. So, and their orbits might also change because these are the gas giants actually. So, so we here impart that this Goldilocks zones are not stable; they keep changing and shifting. So, moving on. Okay, so here is the first exoplanet which was discovered in 1995, and its name is 51 Pegasi b. It like the discovery had already been in 1992, but the real exoplanet, we say that the exoplanet was found around the main sequence star, was this 51 Pegasi b. So it is the ideology of this exoplanets is not very new. Like in back to 14th and 15th century, these two scientists had already some idea about the exoplanets. They had written some theories about it. So now in 1990s, the exoplanets were first discovered, and between 1995 to 2009, 70 exoplanets were discovered, from which like more of them were like Neptune like. So we can say that this period was a very revolutionary for the discovery of exoplanets, probably because of Hubble Space Telescope at that time. And also the NASA had launched the Kepler mission to find out more about the exoplanets. It just recently got retired in 2018, and now the James Webb Telescope have been launched very recently, which would give us more data about the exoplanets and all. And here is a data, like till date the confirmed exoplanets are 4,000. So moving on. Okay, so here is a very interesting activity for you all. You might wonder that the names of the exoplanets are very difficult for you all to like remember. So I'll tell you how the exoplanets are actually named. So exoplanets are named like the first of all the survey or the catalog or the telescope, whoever found out maybe that, or the host star's name is there, like Kepler 22b. So Kepler is the name of the mission, the telescope, or the star. Kepler 22 is the star. So then the secondly there is some order, like the small case, like lowercase b is used for the planets. If the planet is first to the is the if the planet is the first or the nearest to the star, its order number is small b. And if it is a star, it would be like uppercase A, starting from A, B, C, or D. Okay, so likewise, we saw that Proxima Centauri, Alpha Centauri A, Alpha Centauri B. And if it would have been the planets, then Alpha Centauri B, it would be starting from B, lowercase. So now here is an activity for you all to, if you were an exoplanet, how would you name yourself? So first of all, you need to do like name of your parent. So you're a star, and then your date of birth, and then your order, like you're the oldest sibling or the like smallest. So mine would be Manoj 2008B. Manoj is my father's name, and 2008 is my date of years. And D, I'm the third child in the family. So it would be my name if I were an exoplanet. So I would like to ask one of you if you can tell your name if you were an exoplanet. Harsh, can you name yourself if you were an exoplanet?
So according to it, mine will be like Renu 2007, and then I'm the first kid. Then it will be small case B.
Yeah. Ma'am, can you please name yourself?
So this is initial of a person. So this is V. The date is 1st May. The order in which you
Okay.
are born, this is the order in which you were born, you were found. The oldest or only child is the lowercase b. Nay. So, I the oldest or the only child. No, I'm the youngest child. So how can you find it?
Okay. Ma'am, you have how many siblings? Like,
Two.
two. So you would be two. So your father's or mother's name, and then your date of year, and then C. That would be your name.
6. 1st May 1966.
Okay, okay. So thank you, ma'am. Thank you, Harsh. I can see a lot of responses in the chat box. Yeah. So I hope you enjoyed the activity. Moving on. So okay, this is what we have been waiting for. This aliens. Now this is the notion most of us agree that we are home alone. So, like, we are the only, we always assume that we are the only form of life in the entire universe. I say no to this because I think that we are yet to discover the other forms of life on the, numerous, countless exoplanets out there. Just imagine the counts of the exoplanets in the whole, in the entire universe, if 1 trillion of them are there in our own galaxy. One theory says that every sun, like every star, has at least one exoplanet, like have at least one planet. So according to that, in our own galaxy there are 1 trillion exoplanets. And just imagine that there are billions of galaxies in the universe. So just imagine how many exoplanets would be there and what all kind of life would be there. So the concept of aliens comes here, like aliens meaning is foreign, someone who is out of our world. So aliens are the other forms of life which are found on, we think that on the other planets or somewhere else in the space. So the concept of aliens as of now is very futuristic, and it is a like much more like of fiction. We have seen in many Hollywood movies and Bollywood movies, the aliens are portrayed as very strange kind of creatures with long ears, big eyes, and very strange with jadoo, you know, and everything. So when had been to ISRO, I asked one of the scientists over there, "Sir, what do you think of aliens? This is the most interesting concept when we study space science." So he said that I wouldn't say clearly that aliens doesn't exist, like aliens don't exist. They exist. We might find them later on. So just just a bright future in space science. We might find aliens. We might find other form of life on any planet, on any exoplanet. Okay, so Mars, we say that like Mars might have supported life around 3.7 billion years ago, as the remnants of the water have been found on there. So we can say that there might have been life or might be in future. So the question is for the space biologists now that can the life be supported without water? So what all forms of life is there which exist without water? Like we can say there might be some form of life to which the oxygen is poisonous, water is not needed. So this is the question to biologists who might, like, we don't even know till now how many exactly, like how diverse is the life form on our own planet. So it is far away to discover on other exoplanets. So we only have our own planet's example to follow. There could be similar evolutionary pathway, and life adapted to the exoplanet environment could be found out in future. Maybe not quite like us, but not far from looking like our home. We it could not might like it could not look exactly like us. There might be some strange looking creatures, but we would not say that we are home alone in the universe. We cannot say this. This is yet a mystery. So we are yet to find out the life on there. So leaving you with lasting inquisitiveness. Here we end. Here are the sources through which we collected the information. So we thank you. And yes, Harsh is posting a link of the form through which you can test your knowledge on exoplanets. Please do it. Thank you from my end.
Thank you, Apurva.
That was a spectacular presentation, Harsh and Apurva. I'm sure all of us now have a better understanding of exoplanets and the Goldilocks zone, thanks to your detailed explanations and the fun-filled activity that just glued us to our seats. I would also like to take this moment to thank our teacher mentors, Rachna ma'am, Gulfam sir, and Vinita ma'am, who have helped us make our workshop exponentially better. Participants, now that we've explored the universe on a grand scale, how about we dig in deeper? Maybe explore the violent side of the universe. Well, if you want to know about black holes, supernovae, quasars, and many such celestial matter and phenomena, then you are in luck, because in the next session, we would be exploring just this. Before you leave, just one small question. What is the only thing that can escape a black hole? And the answer to the question will be given at 11 a.m. next Saturday. Stay tuned and join next Saturday to know the answer. And you can also fill out the form that Harsh has sent. Thank you.